There we go. Hey. All right, it's 2 hours UTC, and it's once again Astronomy Daily Live. So yeah, hope everybody's doing well. Everything's good here. Yeah, yesterday I woke up and my head felt a little heavy. I'm like, okay, whatever. And then about noon, man, it just like, bam, and it was almost like a migraine, and like, oh no. But I know exactly why. And
Alert!
alert. Why is because the lady of the house is out. Okay, she's out, and when she's out, all of us here just are very, very sad, and we mope around, and it's like the end of the world, because our entire universe is just gone, right? So all of us here,
Now you can see.
are just not in any good mood at all. And what I noticed, see, I'm doing things, right? I'm doing stuff. Not in any kind of crazy, wild way, but I'm working on things, and I've got stuff going on. I forget to eat. And what I realized yesterday was that it's like, you know what? I don't remember the last time I ate anything. So I'm pretty sure that that's what it was, because as soon as I, started to eat things, it's like, gee, I sort of feel better. So yeah.
I wish I had that problem.
Yeah. So actually, I probably could have live streamed last night, because I was feeling better. I was feeling just fine. And I'm like, well, I've already sort of, axed it, so I'm just going, to take it easy and all that, and sort of preparing for this morning. So if you all didn't know, Pamela Gay over at CosmoQuest celebrated the 10-year anniversary of 365 Days of Astronomy. They've been doing a podcast every single day for 10 years, which I mean, that's awesome, right? So they asked me to make a contribution. I'll get on their live and talk about anything I want to, and so I did, and that was really, really great. I talked about the Lunar Observatory project that I sort of have in the back of my head. I'm trying to plant seeds, right? I mean, I can't do a lunar observatory. Come on, but I'm trying to plant seeds and ideas and all that, and I think it's a viable thing. Anyway, so yeah, so hey, I want to say hi to everybody in the chat first, and then I'll get to everybody on the panel. So Uncle Bill, hey. Carolina Sky Astronomy, Jim, nice to see you again. Chuck, nice to see you as well. Deep Sky Dude, hello from the Texas Star Party. All right. Yes, I didn't realize that was going on. The Texas Star Party is and has been one of the largest gatherings of the amateur astronomy community for decades, so Deep Sky Dude, how many people are there? How many telescopes are there? It's always been absolutely huge. I'm sure it's absolutely insanely huge now. And most important question, is it clear? Are you going to be observing tonight? That is the most important thing. So yeah, well, welcome everybody. Welcome. Glad everybody's here. So hey, let's get right on to the panel. So I'm just going to go down my line here, and we'll see how it goes. So Tim, all the way from the UK, how you doing?
All good from the UK. I just want to say thank you to some of these guys in here that was in my channel earlier. Thank you so much.
I missed it.
It was fun.
Absolutely.
And I want to apologize to Carol for my friend. He does have a weird sense of humor, but he is all joke.
Really.
Now, one of the really important things for me here on this live stream, and I think on yours too, Tim, is that I really want us all just to be ourselves, right? We're casual, we're friends here, so be yourself, and if whatever that means, and
you don't know Heath.
well,
honestly,
yeah, but still, here at least, no apologies are necessary at all. On this live stream, just be yourself as much as you can. Like I said, the only difference between what you see here and what you would normally see is this, right? I don't do this, right? I am the silent type. Except when it comes to talking about astronomy, I love it. I love it. So, given the opportunity and some kind of a platform, absolutely, absolutely. All right, Patrick. Hey, what's happening over there?
Hey, what's up?
Patrick, I'm confused.
Better or what?
What's that?
Migraines or something?
Yeah, well, like I said, my better third is not here, and when that happens, we all suffer greatly. And so yesterday, I got this pretty much a migraine, I guess you'd say, and then it dawned on me. It's like, I think I just haven't been eating all that much. So as soon as I started to eat, it's like, gee, I feel better. So so that's how that goes. Now, Patrick, I do have a question. I'm confused about where you're located. Are you in the United States? Are you in Europe? Where are you?
No, I'm not in.
You know where you are.
Chelyabinsk. I'm in
Chelyabinsk. Yes, of course.
You know where Cincinnati is, Dayton, Ohio, in that area.
Okay, cool.
Yeah.
Nice.
Oh, yeah.
Nice.
Sure, I was born in Ohio, more or less.
Oh, that's the problem. I got it.
That explains a lot. Yes. Yes.
Yeah, the exact location's Kettering, Ohio. So.
Okay, cool. Okay. All right.
But every time I pump 45409 into your weather thing, it comes Russia. So.
It does chill.
By the way,
you
sorry to interject. I just want to say hi to Donna ERT.
Hey, how you doing, Tim?
All good, mate.
All
Sorry,
right.
I didn't want to leave it so long without saying hello.
Thank you.
All right. Awesome. Speaking of ERRT radio,
Yeah, I got my adapter today.
That's a super adapter. Holy moly!
Metal gears on it, which is amazing. Okay.
So that's for your smart.
Yeah.
That's for your smartphone to put on your.
Now watch
scope.
this now. This goes sideways. Can you see that? It goes sideways.
Yeah.
Okay. Then then it goes up and down. Okay. Can you see that movement there?
Right. So X,
Okay.
X and Y.
Yep. And then goes for focusing it. Yeah.
Wow.
So the phone, it doesn't work so well with the case on it, but I have gotten it to work with the case on it. So I prefer to use it with the case, just because the case is there to protect the phone. And when you're talking about $1,000 phone, you don't want it to break, you know?
No.
So it goes in like that. Okay.
Okay.
And then, so when you line it up to where the eyepiece is over the camera part.
Okay.
Okay. And then you just move it up or down to line it up. And then, of course, to focus it, you just change that like that.
What does that mount onto, Don, or does it have a carry handle?
This here.
Yeah, I think it mounts onto the eyepiece.
Right on the eyepiece. Right on the eyepiece. The eyepiece goes through here.
Cool.
Okay. And I don't know if you can see see it or not, but
Yep, we can.
it's set up like that. And then I would tighten it down. Now you tighten it down, it will, of course, hold on a little bit better.
So how much does that whole thing weigh with the phone and everything?
Not as much as my Pentax DSLR.
Okay, nice.
So that was the goal, you know, to lessen the weight on that situation. The DSLR did work, believe it or not. The DSLR did work, but it was just a little heavy for it. So, but
so nice.
this particular adapter here is very nice, and it's really easy to use, obviously, as you can tell.
Right.
And it should work for me not having to handhold the phone and trying to line it up. So once I get it lined up, I'm gonna test it probably tomorrow if the sky is clear for the sun. I was gonna do that today, except we had snow this morning. Then we had rain. Oh man, no break.
No break at all.
Should call your place 4 seasons in one day.
Yeah, exactly. Yeah. But nice thing, the snow didn't stay around long. The rain washed it away, so that worked out good. So driving is fine.
I have had clear skies all day long. All long, and so I was like, you know what? I am ready. I'm going to go out. I'm going to do exactly the same 2 objects I did the other night. But I'm using a different filter because that gives you color information, which is scientifically really, really valuable. And so I was planning on this and planning on this and planning on this, and I look at the satellite loop around 5 o'clock my time, a couple hours ago or so, and these high clouds are just sort of forming out of nowhere and blowing right over me. So I'm looking outside now, and I've got these thin, high clouds.
Oh yeah.
That I can see through, but it screws up the starlight, right? So it's like Anyway, all right. And Atta, hey, how are you?
Well, good.
I got to tell you, she was the highlight of my live show tonight.
That was because of Heath. Heath is terrible.
Granted, it was a 2-way thing, but you really made it.
That's great. That's great.
Hey, where did Bobby go? Bobby left.
Yeah, Bobby's been popping in and out. So
did he have internet issues?
It sort of looks like he might have some connectivity problems of some sort.
He said some sort of squirrel ran into a transformer
Oh
around his area,
no!
committed
Oh, wow.
suicide on a transformer.
Oh boy,
no. Yeah,
that's not good.
That's no good at all.
That's
So,
not.
yeah. All right. Well, good. I'm glad everybody is doing
Oh,
relatively
there he is.
well. Yeah, he's popping in and out. It sort of looks like having a bit of trouble over here. So,
What's up, everybody?
hey there,
All
Bobby.
right.
Hey, Bobby.
Yeah,
I was just asking about you. What happened?
yeah. Let me turn this down. I do to apologize.
Yeah, please. The echo is really, really awesome.
As cool as
My-
that sounded. Yeah, as
Yeah,
cool as
you know,
that sounded.
To my musical ears, it's absolutely fantastic. To my live stream ears, it's like
Yeah. Okay. So what is happening on the Linux side was that when all you is there, I can get some serious lagging.
No.
And when I go to the Chrome OS side, I usually am okay. But I also had the Android turned on. I just turned it off.
okay.
Okay, now,
All
Bobby, are you using hardwire or are you using wireless for your desktop?
My headphones and my
No, for
what?
your computer.
It means your connection to the internet.
Everything it's most. It's Wi-Fi.
Okay.
But it's not the Wi-Fi.
Okay.
It's not Wi-Fi. It's my computer.
Right.
That's having a little trouble trying to get to all of you, and I'm usually having a hell of a lot of trouble.
All right. What I noticed on my
because of
on my radio station, what I noticed when I'm doing a show, and if I have the Wi-Fi turned on the desktop, which I just figured out how to turn that off, and I don't have to have it on. I just have the wire connected. I don't need the Wi-Fi on. And I kept seeing a low bandwidth error message when I was broadcasting. And it was like, well, why am I getting a low bandwidth when I'm using a hardwire? I shouldn't have any bandwidth issue at all. And so I realized then I turned off I turned off the Wi-Fi, and I'm still hardwired, with the cable, so I have no issue with the low bandwidth anymore. So just a thought.
Okay.
If you can use a wire, if you have an area where you can get to the router and use a wire, I would recommend doing that.
Yeah, turn off your Wi-Fi because they'll both compete for bandwidth.
Yeah.
Yeah, but I don't. But everything, I can't just have everything hardwired. That's about it. And of course, my Chromebook does not have an Ethernet cord. You gotta get one of those USB dongles in order to get Ethernet.
Okay. All right. Well,
but like I said, it is not the Wi-Fi's fault. Okay.
Right.
It's my computer on the Linux side's fault.
Not accepting it. I got you.
Not being able to handle all of you.
It just can't handle all of you.
Switch to the Chrome OS side in order to get everything done.
A lot of things couldn't handle all of us, Bobby. So.
That's right. That's right. And that's just how we like it. All right. Well, cheers. I've got a little bit of coffee left here, so cheers to that.
Coffee.
Mm-hmm. Absolutely. I was actually
don't want to advertise, but coffee right here.
my favorite coffee of all time is Kona coffee in Kona, right? In Kona. Oh, that is.
Wait, where's Kona? Where's Kona?
I don't know, Kona, Hawaii.
Oh yeah, okay.
Is
that
that something? Is Kona coffee is something you order online or what?
yes, you can get it. It's like $50 a pound.
What about now?
What?
So yeah, even over there.
I'll be
No.
getting my coffee
But
at
look,
Walmart. Thank you very much.
but it is like the Mount Everest of coffee. Once you experience Kona coffee, this is like, just not. I mean, it's adequate. I mean, I can't afford that either, of course.
For
But
$50 a pound, it better be more than adequate. I better get a
Even-
high off of it.
even yeah, really, even in Kona, okay, it's $25 a pound. So, but I gotta tell you, it is the best coffee that I've ever had. And when I'm over there, that's all I'm gonna drink is that, because that's the only time I can afford it. So, anyway,
You go over there a lot.
no, not anymore. Not anymore. So yeah, that is over. I between 2003 and 2007, I worked for a company on Maui, and would go over there often. And I went to a couple of conferences over there too, on the Big Island, and that's when I first experienced it. And it's like, oh, it was just absolutely awesome. So this is adequate, but it's like compared to Mount Everest, it's sort of like walking up a little hill. It's still a good view, but not the same. Anyway, so I've got the HOH here too as well. Cheers.
I'm gonna get some of that. I can't believe it.
That is just my opinion. So I don't know if many people share that opinion. I think they do, and I'm not quite sure why it's so expensive. Except that kind of coffee is just grown right there. So
My biggest problem is when I get something I like to drink a lot, like a certain beer or something like that, it always goes away. I don't get it. So
I'll stick to Yorkshire tea.
I mean, like Rolling Rock, for instance. Rolling Rock used to be bottled in Pennsylvania, right?
Yeah.
And all of a sudden, Budweiser took it over, and it went to crap. Rolling Rock is no longer Rolling, and yeah, it might still be labeled Rolling Rock, but it ain't Rolling Rock.
Wow.
Yeah. So, just saying that when you get attached to something, be careful.
Right.
Chances are it's going to change. So enjoy the moment when you have it, and that's what's in there.
Yes.
Well, my personal favorite is Everclear.
Oh yeah, yeah,
Oh,
I remember that. Everclear and White Lightning, Lightning, and there was another one we used to drink.
Takes a real woman to drink Everclear.
Yeah, we used to race go-karts in North Carolina. I lived down there by the raceway, Concord Raceway or Charlotte Motor Speedway, and we used to race go-karts there, and we used to use the 180 proof alcohol as fuel, and then we'd drink it. We'd sit there and drink and run the engines off the same stuff we were drinking. I don't know how we survived those days, but we did.
Oh, I don't know either.
Well,
so every time a car broke down, you'd all rush over to it with a pint glass.
Yeah.
I think that any substance is fine. Just be responsible if you can, right? Just be careful. Don't overdo it. Don't
There's
hurt yourself.
too many people now these days getting arrested for DUI and DWI now these days.
Well, back in them days, in the 90s, that wasn't necessarily a law at the moment because they didn't have so many deaths on the highway with the alcohol. But now, of course, that's all changed, and now you got to be, of course, responsible and really careful. I'm not saying that we didn't have to be responsible back then. I'm just saying that it was a little bit more relaxed back in them days in '91 when I was living in North Carolina. Okay, so
Yeah.
Yeah,
You just gotta be,
NASCAR was started by moonshiners, says Jim from Carolina Sky Astronomy.
absolutely.
Yes, it's been a while. It's been a while since I ever watched NASCAR. I think one of my listeners told me when Jeff Gordon retired, he just stopped watching. I don't know who does NASCAR now these days. I don't know. It's because it's been a good while since I watched NASCAR.
Right. Well, the whole idea there, right, with the moonshiners is that they could do their thing if they could drive faster than the cops.
oh yeah,
So they had to modify their cars, to be able to go faster. And so, yeah, Jim's exactly right. The moonshiners are the ones that started that kind of thing because they took stock cars and they modified them, they pumped them up, so they beat the cops. If you can, beat the cops, you don't get caught. It's great.
I just wonder if anybody's seen Clock Stoppers.
Clock Stoppers?
Don't ring any bells
here. It's so Clock Stoppers is a movie pretty much in the early 2Ks, if I recall correctly. Some dude made a watch, a specially kind of watch that when you just by hitting the button, you can actually freeze time and you can do anything you want. Something called hyper time, they call it. And when you're ready to restart time, just hit that button again, and here comes the pranks.
Okay, yeah, that was actually that was also I think a Twilight Zone episode did that, and a Star Trek episode sort of dealt with that as well. So
wasn't there also a Tom Hanks movie? I think they called it Pause or something, where he pressed the pause button and life just paused.
Oh, that was Adam Sandler Click.
Sorry, I beg your pardon. You're right.
Click.
Yes.
Yeah.
Yeah,
that was interesting. I like that.
Right. Interesting. Yeah. Well, messing with time is an interesting concept. I don't know. I don't think that we know enough about time. Some people think that it doesn't even exist, that it's just sort of an
illusion.
Yeah, it's just some sort of a measurement of change.
Well, it's a variable, not a constant, for one thing. And the current theories seem to state that time and space are a continuum. They're not as separate as we've thought of them for years.
Yeah. Well, relativity, of course, combines those two things into one structure, I guess you'd call it. And you really can't separate the two. Without space, you don't have time, and without time, you don't have space. So who knows?
Here's a good question about that.
If I have a choice between Clock Stoppers and Click, I would definitely choose Clock Stoppers, because on Clock Stoppers, they really knew what they were doing when they were going into hyper time and stuff.
Are you sure? How do you know that?
You need to watch Clock Stoppers, okay?
All right.
Do not just try, do it.
Well, I will definitely.
Here's a question now about time. All right, speed of light now. The speed of light is constant according to us here, right? Constant to our laboratory on Earth here.
Maybe.
When we get out to space, does the speed of light stay constant?
Well, for one, the speed of light, that value seems to depend on the medium through which the light is traveling. So, but given a certain medium, it seems to be constant. What's happened, and I think this actually happened in 1973, the speed of light, that number was sort of set in stone. It's like, this is what it shall be. The interesting thing is that what I've heard, at least, is that very, very careful measurements of the speed of light indicate that it does seem to change, and that presented a problem. So that's why they sort of set it to a certain value, which is actually the Planck length divided by the Planck time. If you divide those two values, you get the speed of light.
But we're not sure. We're not sure what the exact length is to certain areas.
Well, the Planck length and Planck time, I think those. That's a good question, Ron. I'm not sure either how those two values are sort of measured, but they're very, very, very small numbers. I think the Planck length is like 10 to the minus 43 meters, and I think Planck time is I'm not exactly. I mean, they're very, very, very small values. It's like the shortest thing that we could possibly measure, and the shortest amount of time. So yeah, all of this gets really, really squirrely, though, really, really, really fast. And so I think that is one of the reasons why we sort of decided that it's like, okay, the speed of light shall be this value. And I think it's 300.
It also has to be measured in the same medium. I mean, when you're talking about the speed of light, you're talking about in a vacuum.
Right. Yeah. Well, and that's why we can see rainbows, is because the speed of light is sort of dependent on wavelength as well, traveling through two different media, like air and glass. Red light, will travel slightly differently than blue light, which causes them to split apart, and so we can actually see a rainbow. So yeah, it gets really, really squirrely, really, really fast when it comes to light. One of the interesting things about a photon traveling at the speed of light, what that implies is that photon is everywhere all the time.
Mm-hmm.
And that's just weird, right? How can a photon be everywhere in the universe?
Right.
Well, it is. It is, according to the theory. And, that sort of gets a little squirrely. So, I don't know. There's a lot of things that we just don't know. We've got good guesses on, and we're probably completely wrong. So,
well, our mind is sort of limited to our own experience, and what we can understand mathematically is not the same thing as what we can picture mentally. I mean, I can't picture a space-time continuum in my mind. My mind doesn't live in that world.
Yeah.
Now, okay, so Chuck Naglam, I think of he's being a little bit contradicted, because he was saying that, speaking of the speed of light, Hubble found that the universe would be expanding more slowly than when they were looking at the local universe. from what I read is that Hubble is doing it much more. That they're seeing the expansion going much more faster than usual.
Yeah,
But I don't know who can agree.
yeah. There is kind of a problem at the moment because we can measure this so-called expansion rate. It's this value called H naught, the Hubble constant, and it's turning out that we can use like two different methods to measure this expansion, and we get two different numbers. And so it's like, what's going on, right? The methods that we're using, to measure those kinds of things are either wrong, or the physics, we don't understand the physics yet,
or just a bunch of talk. Backtracking to the rainbow. I was in a rainbow one time when I was in North Carolina, and it was all I saw was yellow. All I saw was yellow, and I did not see the pot of gold. That kind of really pissed me off. But anyway,
every single time I look too, and I don't see it either. I guess it's just not meant for us.
All right.
That's all I can, Yeah.
But everything was yellow, though. All I saw was yellow. I don't know if that's how it blends together or what.
You mean the rainbow itself was just yellow?
Yeah.
So
but then I don't know. I'm not sure. The rainbow itself had the other colors, but where I was at the end of the rainbow, on the land, all it was yellow.
Do you have a lot to drink that day?
No. Not that day.
I want to know if you found that bloody pot of gold at the end of the rainbow.
No, it didn't have any gold there. That's a lie.
Bummer.
No gold either. Yeah, it's hard to know. Light can be scattered by dust. Yeah, that's a pretty strange thing. So
I saw something one time of a circular rainbow, just a pure plain circle. It's not coming down to the ground. It's just up in the air, just a circular rainbow.
Does such a thing exist?
Absolutely.
Yeah.
Oftentimes, you'll see sort of a ring around the sun, and that's at 22 degrees, if I remember right. And sometimes, depending on the conditions, it can actually diffract and make a rainbow like effect. So that's a relatively common thing. The conditions have to be just right.
So that's not really a rainbow as we know it, is it?
Well, it's the same kind of thing, right? It's this stuff.
Yeah.
Light refraction.
Yeah. It's not exactly caused by the same thing, but yeah, that's relatively common. Yeah. So
now, out of my curiosity, have you ever seen a night rainbow or a moonbow?
Yeah.
Oh yeah. Yep. Absolutely.
Yeah.
It's actually exactly the same thing. It'll also be at about 22 degrees away from the moon. The moon will be here, and then you'll get a nice ring around there at 22 degrees. And that's just the nature of this amazing molecule in here.
I've seen a full circle around the sun and the moon, and not seen various colours in it. It's been pretty much one colour. Is that the same thing? I would consider it a halo.
Yeah. I mean, oftentimes it's a halo. Depending on the conditions, you might see some color. Yeah. It's just one of those things you just have to look out for. Patrick, you're exactly right. It can be called a moon dog. That's another weird kind of optical effect where you have these two bright things right on the sides of the sun, sometimes on top, sometimes on the bottom, and then you'll have a ring around those. Trying to think there, you can look these kinds of things up. There's all kinds of really, really neat patterns that can actually be made. The rings can actually go up like that, and then you'll have a ring around there.
Now, doesn't that matter? Does that matter depending on how much atmospheric conditions, and will that be a way to tell if we're going to get rain?
Yeah, I don't know about predicting any kind of rain or anything, but yeah, it has everything to do with the atmosphere, right? What's up in the air, ice crystals, liquid. It's pretty amazing. And yeah, I think it sort of depends on temperature. It depends on your latitude. Yeah, I think it depends on all kinds of things. It gets really complicated really, really, really fast. So, as does most things. So, all right, well, cool. Well, cheers to all that. So I thought what we could do is just sort of take it a little bit easy and just do a simple little object of the day in the few minutes that we have left. So let's let Nightbot. Let's go ahead with a random NGC object and see what that does. So Nightbot, there's a command in there called NGC, and it's going to theoretically at least choose a random number between 1 and 7,840. So there's 7,840 new general catalog objects, and these are mainly non-stellar objects, so things that aren't.
So if we're going to look at an NGC object, I would just do the command for you.
Oh, thank you, sir. These can be galaxies. They can be clusters. They can be nebulae. They can be in the north. They can be in the south. The only thing that this catalog sort of follows is right ascension. So the small numbers start at 0 hours, and then they wrap all the way around into 24. And so, well, there it is. So we got our NGC number for today, 6397. So I've grabbed the handy dandy calculator here, and so I always like to sort of predict the approximate right ascension of that. So if I take 6397 and divide it by 7840, and then multiply it by 24, I get about 19 hours and 34 minutes right ascension. So let's see how close we actually are. It might be illogical, but I'm going to do it anyway. So here we go. I'm going to go over to Sinbad, which is a great.
Wait, now what is the math function again? You go, what?
Oh, okay. So what I want to do is I want to. Where's my screen here? So I'm going to take 6397, and I'm going to divide that by 7840. So that'll give me.
Why 7840?
7840 is the total number of New General Catalog objects.
Okay.
And so I'm just getting, I'm going to change that number, to go from 0 to 1 instead of 0 to 7840. And then I'm going to multiply it by 24 hours. And that's how I get the
6390 divided by what?
6397 divided by 7840 will give you like
19.58 and some change.
Right.
Okay. 7397 divided by what? I keep forgetting.
7840? 7840, which is the total number of objects. And then you multiply that by 24 hours because, 24 hours is an entire circle in the sky.
And that will give you the location of where the object is.
Approximately.
Okay.
So I got 19 and a half hours.
Yeah. And if you convert that to hours and minutes, you get about 19 hours and 34 minutes. So let's see how close we are to that. So, okay, so now I'm going to go over to Simbad. And as soon as I load Simbad, I will share my screen. I'd love to do. Because nobody wants to look at this ugly mug for too long.
What's wrong?
Okay, so here we go. Dun, 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 dun. I'm going to share my screen. Just like that.
There it goes.
Kablam. I'll go over here. I'm going to go over here. All right. 6397, right? NGC 6397. It's now most of the NGC objects are galaxies. So this is probably a galaxy. Maybe not. Carolina Sky, I think, mentioned that it was something already, but that doesn't help in terms of what it actually is. Let's see. Oh, it's a globular cluster. Nice. Okay. That's a nice looking one too. It's way down in the south though.
Oh, it's in the south. That's why it's below the horizon for me.
Yeah.
And it's also
that was nice,
Cadwell 86 as well.
Yeah, nice. So we can see here that the right ascension is actually 1740. So yeah, not exactly matching the calculation. That's fine though. That's how it goes. But yeah.
So how can we correct that to match up the answer correctly?
It's just approximate.
Okay, so I just fast forwarded to about. It's going to stay deep in the south.
Yes. It has a declination of negative 53 degrees. So that is very, very far south. For those up here in North America or Northern Europe,
you can just say forget about it.
Yep, you are not going to see it at all. But I've snuck over and caught a peek of that, and wow, that's a very, very rich globular. So we'll come back to that. Let's see what else is going on with this guy.
Because I know it just rised up. When I was looking at my Stellarium map on my phone, it will rise up about 4 degrees, but it's going to stay just about a few feet from the horizon. And that's just going to be about. So you're right.
It's really
you have to go deeper than deep south to catch that gobbler customer.
Yeah. It's actually,
Probably around South Mexico or before South America, probably.
mhm. the declination of your local zenith, right, which is the point directly above you. The declination of your zenith is your latitude. Um, what that also means is that the altitude of the North Star is also your latitude. Um, so, so if the declination of your
And nobody wants to hear Mr. Fake News. Thank you very much.
who's that? Mm-hmm.
Check.
Oh, okay.
We got rid of the bad guy.
Bam! Smash him. Bash him over the head. All right, cool. So the the declination of your latitude is right at your zenith. So, for instance, my latitude here is about 32 degrees north. So, the declination of my south is actually 32 degrees minus 90 degrees. 32 minus 90. So, actually, the declination of my southern horizon here is negative 58 degrees. So theoretically, I could see this. It would rise, 4.5 degrees above the horizon. So in theory, I'd be able to see this. Bobby, you definitely be able to see it too. But it's going to be insanely low, right? Just insanely low. So don't try. It's not worth it.
Let's take a interesting question about this cluster.
Okay.
Or any cluster actually, but mostly globular. How do you say it?
Yep.
How do the stars interact with each other? So, for instance, they're all attracted to each other for some reason.
The going theory is that the globular clusters formed about the same time that the galaxy formed. So they're sort of approximately the same age as the galaxy. The dynamics of the stars are sort of unknown. You sort of have to watch these things for long periods of time. They seem to sort of be buzzing around each other, sharing a common center of some sort. It's theorized that there is some kind of large mass towards the center. Maybe one of these black holes. Maybe, who knows? But these kinds of objects are extremely mysterious. We really don't have a good understanding of why they're there or what they're doing.
Now, is there any binary and triple or trinary systems, or are they all singular in the cluster?
Yeah, good question. They are really packed together. So,
Okay.
when do you decide when you have a binary or when you have just two stars that are really close to one another? What's the difference? And in this case, we're talking about most likely tens of thousands or maybe even more stars here, and they're all just sort of buzzing around each other. One of the things that is really, really hard, as you can see in this picture, is trying to pick out, the individual stars. If you can't pick out, the individual stars, it's really hard to measure what each star is actually doing. You can sort of get a good sense of sort of the general motion of things, but the motions of like this little star right here might be easy, but try to pick out an individual here. Right? It's really, really, really hard. What we should do is go over to the Hubble archive and see if anyone has observed this particular object. Let's do that. Because, this image here is most likely taken with a telescope that's on the ground. And, that means that we have to look through a lot of atmosphere that blurs the image a lot. Like in this case, the center here is totally overexposed, right? It's just a big blob. But the HST...
We're about to lose Tim.
About to lose Tim? Is he nodding off?
Yeah.
Right,
and we're about to lose Otto as well. But before you go, you might want to check the chat and then I might tell you something what you're going to do the next time you see him again, face to face.
All right, Tim. Well, have a good night.
All right, Tim.
All right.
Okay, my apologies, guys. I really am ready for blanket market.
Absolutely. It is almost 3 a.m.
If we would ever see that dude, now if we ever get to see that dude again, you might want to get those crab grabbers. Might want to dip them in some ice cold water or just ice, and pinch and pinch like the centralizer. Now, I'm not telling you what a centralizer is. And if he just taps and just cries for drama, for sure he is not worth it.
Now, this is not a violent live stream here. We can just, simply take a hammer and just, smash it. It's all we've got to do. No problem at all. So yeah. All right. Well, Tim, you have a great rest. Atta, you take care too. We're gonna take a look at this object, hopefully with the HST here, and see if we can find anything. But
and that's why Trolls ain't worth it. Trolls ain't worth it. Trolls ain't worth it. Trolls ain't worth it.
Yeah.
Okay, guys and girls, I bid you all good night.
All right, good night.
You take care.
Thank you very much indeed, Matt, and everybody else. You all take care.
Come on back whenever you want.
Bye for now.
All right, you take care. Oh, I didn't mean to do that.
Now, the one galaxy I got to look at a while back when I had this Electron 2000, Ultimate 2000.
Yeah.
I got to look at the Hercules M13.
Ah, yes.
And that was incredible.
Yes. Yeah,
that scope was incredible when you had it all lined up and you could punch in the name of the object and go right to it. That was like one of the early stages of that go-to system.
Yep, very, very cool. And another one you should definitely look at. It's sort of in the same part of the sky is Messier 5, M5.
Oh, yeah.
That's even bigger. And
but now the Hercules looked like it was a blue snow cone to me.
Yes.
In North Carolina, anyway.
Very cool.
So.
Very cool. Yeah.
I guess Tim was going to turn to a pumpkin. I think Otto just turned. No, Tim is about to turn to a potato.
Okay.
Otto's about to be turned to a just turn to a pumpkin.
All right.
Makes me want to think. Well, if women can turn into pumpkins at night, does men actually turn into potatoes at night as well?
Well, apparently so. Hey, look at that. So HST has looked at this object. So yeah, let's take a look and see what HST saw here. So looked at it relatively recently. This looks like it was in the infrared. I don't know if this is going to be available yet. So let's take a look here.
So why is our sun all by itself?
It's one of those relatively rare objects.
Because it's strange to have a single star, from what I understand.
It's relatively rare. Yeah, it really, really is. So yeah, maybe that is one of the requirements for life. Who knows?
For how we got situated here.
Yeah. So here's it looks like they were looking at one section of the cluster here. I'm gonna see if we can find something maybe a little better. So this is looking in the infrared. Let's look at this one here towards the ultraviolet. It's a separate observation, but let's see what that shows. Okay, so it's showing. Yeah, well, that looks like, I guess that's showing the whole cluster. You can see that there is quite a difference between this ground-based image and the HST image, where you actually can now pick out the individual stars. It's kind of interesting that there's a bunch of these guys that all look like they seem to be about the same brightness.
Yeah.
So kind of interesting. You can definitely tell, there's a concentration here, but you can also see that the HST, you can see all the way down, all the way into the middle here. So that's pretty cool. Once you can do that, then you can start measuring the motions of the individuals and see what they're doing, and then get a conglomeration of these things. The other thing that, we could go over to Gaia and actually see what kind of measurements were made.
Now, if there was a planet like Earth in the middle of all that, would that be incredible to see all them stars?
I think it would be very incredible. Yes, yes, because
if it was a possibility.
Yeah, I mean, there's thousands and thousands of stars here at least, in a relatively small area. I'm just going to throw out a guess here that this is, maybe a couple hundred light years across. It's hard to tell, right? So the spacing in between these are still maybe a light year or so across. But
here is Mr. Lurker, also known as Uncle Bill Thruin. Fraser James said today that his new favorite myth-busting statement: turns out we're finding lots of brown red dwarfs and learning that single star systems are much more common than we thought.
Yeah, he that I actually heard too, and he's actually right in terms of numbers. Single stars, there are actually more of them because we're finding a lot of red dwarf stars, and those seem to always be single stars. So numerically, there actually are probably more single stars, but in terms of visible stars, they oftentimes occur, in some kind of binary or or more. So yeah, that's absolutely true. What Fraser said. He said also, that he likes to mention that, to throw off astronomers, because most astronomers were taught that yeah, most of the stars that we see are multiple stars, and that's still true, but depending on how you look, right? When you're looking at all these red dwarf stars, that there are lots and lots and lots and lots of those. Those do tend to be singles. So yeah, numerically, he's exactly right. So and right. Um, just as Uncle Bill says, the low mass stars don't tend to be binaries. So yeah, there are so many things that we just don't know, and there are even more things that we don't know that we don't know. so
I think that's about it.
I love it. I love it. That means I get to keep my job. So
Oh yeah. The more questions we have.
Yep, I'll always be an astronomer, because there are so many things that are just so unknown that yeah, there will always be work to do, and we're developing the technology now to provide us with all of this data, and it's just an insane amount of information, which the astronomical community is gonna, they're working on trying to deal with it, but it's a huge process. All right, well, let's keep looking here at now. Let's actually see what these folks were looking for. Why?
Uncle Bill just said so is relatively low mass and dim compared to the rest of the visible stars, right?
Uncle Bill, I would say that at least my understanding is that our sun is sort of like right in the middle of things. It's not necessarily very low mass. It's not necessarily dim. It seems to be right in the middle, which is sort of conspicuous, right? That to me is sort of like a red flag too. But we sort of make observations, and we can plot things like the Hertzsprung-Russell diagram, and it seems as though the sun is just sort of a very, very, very average star. Still extraordinary, but relatively average. So anyway, let's see what these guys. I wonder why these folks were actually looking at this cluster. So we can go over to their proposal and sort of see what they were looking for here. So let's see, this ultraviolet initiative proposal, database of the AC. I'm not quite sure what the ACS globular cluster treasury is. So they're looking at globular clusters with these three different filters. Uncanny ability to disentangle and characterize multiple population patterns in a way that's exquisitely sensitive to carbon, nitrogen, and oxygen variations. Combinations of these pass bands with the optical ones also give best leverage for measuring helium enrichment. The dozens clusters so far observed in these bands exhibit a bewildering variety of MP patterns, multiple population patterns. Okay, yeah, so they are observing globular clusters at these three wavelengths, right? They're talking about 275, 336, and 438, and that sort of allows them to separate, the stars into different populations, which apparently is extremely interesting. So that's kind of cool. So yeah, here's the which one was that? That was the 275. So that is looking at 275 nanometers. They've got one for 336, which is going to look pretty much exactly the same, at least to our eyes, and then at 438. So again, pretty much exactly the same. If we were to line these all up, put them into GIMP, colorize them, we'd actually see some pretty good differences with the colors and all of that. So yeah, pretty cool. They're trying. Yeah, this actually gets back to Ron's question about what is going on with the individual stars. Why are they the way they are? And so looking at them with these different.
So Uncle Miller's also say so Dr. Pam Gay can still say 4 out of 3 stars you see in the sky are usually binary or trinary.
Yeah, 4 out of 3. Yeah, absolutely. That's great.
It's kind of a bit strange about me, but it's okay to be a little bit or not too much awkward, but too much awkwardness, there's going to be a problem.
Well, you're in the right place then, Bobby, because at least as far as I'm concerned, I am definitely tilted very much. So and I thoroughly enjoy every minute of it. So yeah, you're in the right place. So it's kind of interesting too. I'm not quite sure why they did this, but do you see the exposure times that for the shorter wavelength they went really, really long, and for the longer wavelengths here they went really, really short. So I'm not quite sure what's going on there. They probably don't want to overexpose, because then they lose a lot of information that way. So they had to vary their exposure times pretty significantly here, I guess, not to overexpose.
I skipped the message too. My point is that we wouldn't see it well from very far away. The sample we see easily is skewed to the large and bright.
Yeah. Yep. That is very, very true. All right, let's keep now. This is kind of a little weird here, right? It says target name and then it says any. That's, I'm not quite sure. I don't know if that's an acronym or what that is. ANY.
That's why sometimes we need the any key.
I suppose so. You can sort of see, the right ascension and declination. They're pointing pretty much in the same place. So I don't know what's going on there. Let's just take a look, see what it looks like. Okay. So yeah, it's looking at the same thing. It's a little offset. I don't know why it's called ANY though. That's a little weird to me, but okay. I wonder if the proposal ID says anything about that. Different observers, of course. We propose to obtain second epoch images of the globular cluster 6397, which has the deepest ACF WFC dataset ever obtained. Okay, that's kind of interesting. So when they say deepest, they mean longest exposure, right? They've really looked at this for a long period of time. You can see.
Well, and speaking of awkwardness and everything else, Cosmic, did you ever see that Check Me Out is finally done with school?
I noticed that you posted something about that. Yeah. So good. Well, I'm sure that she is extremely relieved to now have her piece of paper, that says that she's accomplished this. That's a great accomplishment, of course. So she now hopefully has the knowledge and at least a little bit more credibility, and she'll do great. She's awesome. She's absolutely awesome. These lines here are what's called bleeding. It's a CCD CCD thing. When you overexpose, the electrons, it's just like filling a bucket too full, right? When you start to pour in more than what the bucket can fill, it'll start to overflow. And so that's what's happening here, is that you just get what's called bleeding. So this is indicative of a pretty long exposure, because you're pouring photons into these buckets, and they're flowing over. And so even these faint guys, you're starting to get bleeding. But the point is to try to pick out these really faint little dudes here, which may or may not be actually part of the population. They might be background stars. They might be foreground stars. Just this picture alone isn't going to tell you much, but it is certainly a long exposure, very, very long exposure, which I think was sort of the point, right? Is that they wanted to look at very, very faint objects like white dwarfs, which are extremely interesting objects, but because they're so small, they look really, really, really faint. And so, yeah, it sort of looks like that's what they were after. Was trying to understand the population of white dwarfs within these clusters. These clusters are pretty darn far away. We can actually go back to Simbad and look and see about how far away this guy is. And I'm noticing what time it is, so I don't want to go too much longer here. But let's see. So, all right. Well, yeah, they measure these things in mega parsecs, millions of parsecs, which, on a galactic scale, it's probably not the best units to actually use. But let's see. So a million parsecs is 3.26 million light years. And I'm going to multiply that by 0.002. So that's 6,520 light years away. So, as far as globular clusters go, that's sort of kind of close. The globular clusters, one of the characteristics of globulars is that they tend to sort of hang around the center of the galaxy in sort of a round halo, they call it. And the center of the galaxy is something like 30 or 40,000 light years away. So this globular is definitely sort of on the close side to us. But yeah, to see a white dwarf is definitely a challenge. But if you look at these stars at different wavelengths, white dwarfs are, like the name implies, they look very, very white, not red or yellow. They look, either very, very blue or very, very white. They're really, really bright towards the blue end of the spectrum or towards the ultraviolet, and not very bright in the infrared. So they're actually relatively easy to pick out, because they look really, really, really white. So here, this is a relatively red wavelength, 606 nanometers. They also looked at the cluster, it looks like, towards the ultraviolet. So yeah, the difference between an ultraviolet shot and a red shot is definitely going to show off the blue stars a lot more, or the white stars a lot more. So this is the red one. We can look at the blue one here. And, it's going to look more or less the same by eye. But again, if I combine this into GIMP, which, we might do that tomorrow just to show that off a little bit, because it's getting a little bit late now. But it'd be kind of interesting to see, whether some of these stars look really, really blue or really, really white, because that is sort of indicative of them possibly being a white dwarf star. But it's a pretty cluster, for sure. Cluster. All right. Well,
I just got an announcement before we do get off for tonight.
Yes.
Okay. So next, the Sunday coming up in UTC time, I will not be on the panel board for that time. I'm actually, local time would be Saturday, May 4th. So it would be Sunday, May 5th. I will not be on the panel. I'll be actually going to see some more local wrestling.
Oh, sweet. So that's actually a week from today, right?
Right.
Yeah. Cool.
Oh, you can be on the panel and go to the wrestling at the same time. Yeah.
No, I can't.
Well, you can certainly try, but I think I'd have to mute you.
That's it. So sorry, Ron.
Well, you enjoy your time at the wrestling matches.
Yeah. Absolutely. Yeah. But you've got a week at least. So yeah, I think let's. I don't think that we have really scratched the surface on this object yet. So I think I want to continue with this at least tomorrow.
Is there a formula to, just real quick? Is there a formula to tell the or to estimate the Messier objects?
No, those are scattered all over the place.
Okay.
Mr. Messier, was a comet hunter, so he was looking all over the sky. And when he came across a thing that wasn't a comet, he would note the position and move on.
Oh wow!
So yeah, the New General Catalog, sort of the origins of that was with William Herschel and his sister Caroline, and he was much more uh, um, um, what orderly, methodical.
What is the formula for predicting, say, the moonrise? Excuse me, the moonrise, or like say predicting an eclipse. Obviously, they can do that. You know.
They can. It depends on the orbit of the moon. Just really roughly speaking, the moon goes around once about every month, right? So it goes 360 degrees about every month, 27 days. So if you take 360 degrees and divide it by, let's just say 27, that means that the moon moves about 13 1/3 degrees every single day. And 1 hour of right ascension is about 15 degrees or so. So 13 degrees divided by 15 is going to give you 0.88 hours, which is about 53 minutes. So every day the moon will rise or set about 50 minutes or so later each day. Now, predicting eclipses and all that gets complicated, and we can definitely dive into that. This live stream, I don't want to mess around and say, well, that's too complicated. We're not. No, there's nothing that is too complicated.
Well, I know that astronomy really relies on a lot of mathematics.
Well, reliant. Not quite sure if that's the right term, or the term I would use. It's definitely a very nice tool to have to sort of describe what we see, but don't confuse the mathematics with the thing that's actually taking place. Those two things are different. Mathematics I see as a tool to sort of help us describe things. Why it occurs, that is way beyond math. But great tools to predict things, and that's actually a lot of why science exists, is to try to figure out ways to predict the future, because if you know what's going to happen later, that gives you a lot of power. Science is a nice tool, because it gives us power. We humans like those kinds of things. So, all right, everybody. Well, I am definitely going to get out of here for now. I am worn out, zonked, melting. Let's see. I don't turn into a potato. I'm trying to think about what I turn into. I can't even really describe that. I'm going to have to think about that a little bit.
All right, I actually had this book at one point, long time ago, Practical Astronomy with Your Calculator, by Peter.
I've seen that.
Smith. It was way beyond my understanding, so it just looked cool though. The book looked cool.
Yeah, go ahead.
But yeah, I was gonna say if anybody wants to know more about using a calculator for astronomy reasons, that's a really good book. It does help clarify some functionalities of what's going on. So
Very cool. Very cool.
yeah,
Yeah, all these things are pretty knowable. It just they get really really complicated really fast.
yeah.
But we can definitely dive into those things. It's not that bad. It's not that bad.
I
You
just
just
want
have to.
basic. I just want basic ideas of like how to predict the moonrise or whatever.
Yeah, yeah. Well, like I said, the general rule of thumb is that the moon rises about what um, 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 45 to 50 minutes later each day. So use that as a rule of thumb. That usually works pretty well. That sort of depends on your latitude. It depends on the position of the moon. But
Yeah.
Generally speaking, that's about right. That's about right. All right, everybody, I'm going to get out of
All right.
here for now. Thanks for coming in once again. I will be here again tomorrow, about 22 and a half hours from now. So take care. Have a great evening, a great day. Spread the word. Spread the word. I like to talk astronomy and space and science and all kinds of nerdy things. So come on back whenever you want to, whenever you can, and I'll be here again tomorrow, 2 hours UTC. All right. Peace, cheers, and all that, everybody. See you later.
See y'all next.